Okay, yeah, so hi everyone, thanks for coming. I spoke here last year, I was super excited. This is one of my favorite conferences. I spend a lot of time traveling and I really like Madrid. There's a lot of sunshine here. Yes, I live in right like San Francisco where there's really not that much sun, so it's always fun to be here. I believe the title of this talk, I sometimes forget and I show up and I start talking about something else, is building Google Cloud. So they have this service that takes TensorFlow models and you can train these models in a distributed fashion. And I'm pretty sure the Amazon folks, there's this big conference coming up, it's called reInvent at the end of this month. It'll be in Las Vegas. I recommend staying away from Las Vegas. Yeah, there's a lot of stuff going on there, just like I should probably stay away from Barcelona for these next, is it too soon? Yeah, it's too soon, okay. This is a very busy slide, and we're gonna talk a little bit about C++. We're gonna talk about CUDA. So TensorFlow uses CUDA beneath the covers for GPUs. Yeah, also want to mention we participated, there were 10 startups in this O'Reilly AI conference. The O'Reilly folks are the ones that make all the good books with, the single animal on the front. Yeah, they each have a like unique animal, that kind of thing. So there were 10 startups and somehow we won. So I'm going to talk about the research that went into us winning this startup showcase. This was about 2 months ago in San Francisco. We competed, there was like a robot next to us, and then there was like, all kinds of weird, crazy AI stuff happening. And we're more of a platform. That's what this company I founded about June of last year. It's called Pipeline AI. We're sort of focused on the end of the pipeline, your machine learning pipeline, AI pipeline, and getting models into production. And so one thing, we're not very shy about this, but we are reverse engineering this Google Cloud stuff, right? Like that service that takes your TensorFlow models, and we also support Scikit and our models, and you can submit them to our service. Our service actually runs inside of your right, like VPC or your like Amazon account. So we're not a third-party service. We don't want your data. We don't right, like want your models. We have enough of our own. So we just deploy inside of your data center, which could be your cloud, any cloud. This is all based on Kubernetes. Kubernetes in the Bay Area is almost like talking about water now. It's so common. It's like talking about Linux or talking about Kafka. Let's see. I'm going to have to manually scroll through here. What else? Yeah, so just real quick about me, Netflix. When I moved from Chicago, I was raised in Chicago. Yes, I know you guys are all like basketball fans. It seems like every My Taxi driver or like Uber driver talks to me about Chicago and basketball and Michael Jordan. And moved to San Francisco about 8 years ago to work for Netflix. I was looking for more scale and for more, like complex sort of like distributed systems. And so that's where I found it. Also went to Databricks, started like working with Spark very early on. I'll actually make some like comparisons between Spark and TensorFlow here. So, right, like hopefully you have some experience with Spark as well. Also, I went from Databricks to the IBM Spark Tech Center in San Francisco and helped build that up. So, built it, I think we were 5 people up to like 65 or 70 after about 9 or 10 months. Yes, I also run this meetup. We just started a chapter here, actually, the Advanced Spark TensorFlow meetup. We just did one the other day over at the Biva office. Yes, I like those guys a lot. Is there anyone here from Biva? There's probably a couple people. Yeah. Oh, hey, what's going on? Yeah, so they're very sophisticated group of people. They've been working with TensorFlow since last year. They kind of track along with the Bay Area, based on blog posts that I see and the conversations that I have with these guys. So I really like to collaborate with them. They have a really cool office space as well, too. Yeah, if you, so all of our slides, and, this is a 30-minute talk. Well, I guess now a 20-minute talk. But all the like YouTube slides, SlideShare, or like YouTube video SlideShare, we get a lot of really good Bay Area speakers. We have about 9,000 members right now. We're actually the largest TensorFlow meetup, which is kind of funny, the largest Kubernetes meetup. And we're just about to pass the Spark folks, Databricks, in like the #1 Spark meetup. So yeah, looking forward to that. Also, a couple announcements here. I think you guys probably know. You don't know about my nephew, but you know about Cristiano's new kid. Yeah, obviously much better looking family there on the bottom. I found this thing too that was pretty funny. I guess his rather older son wants to become a goalkeeper, and he does not want this at all. So it's kind of funny. Yes, introductions about you guys. Let's see, yeah, so software engineers, data scientists, data engineers, data analysts, whatever, you want to get these models into production. And the term that kind of goes around, I've been hearing more and more, is this sort of production first thinking, or serving first thinking. So like obviously we're all AI first, we're all ML first, but there's this kind of second step, which is getting this stuff from the lab into production. And so that's the exact problem that Pipeline AI was created to solve. So we've been working the last, I think I have a slide here on, oh yeah, and you don't really need too much knowledge about TensorFlow, but it would certainly help, just some of the terms I'm going to use. But so really, there's this research part, and then there's training the model, which might take a week, and there's ways to optimize that to drop down to floating point 16 precision from full floating point 32, things like this you can do, and start to take advantage of some of these newer GPU things on the actual chip themselves. But then there's this kind of post-training step that you can fuse together your neural network layers, or you can quantize the weights that you've learned, the variables you've learned. Whenever you can drop precision, this is kind of a general theme, either at training time or at prediction serving time, or the inference time, which is the fancy term for prediction. You then make the math a lot simpler. It's way faster to multiply two int 8s, right, than it is to multiply two floating point 32s. And with these new hardware advancements and these new instruction sets, you can actually pipeline and put two floating point 32s onto one single floating point, two floating point 16s onto one floating point 32 GPU core, and do twice the throughput just right there. So we'll mention some of this stuff. And yeah, so one thing, yes, I do this workshop, and actually, spoiler, I'm going to give you all a free pass for Saturdays online. It's a 4-hour workshop, so I'm just going to hand out the code here. You guys can take a picture. I'm going to give everyone their own GPU. I actually did this as part of this conference. There was a lot of interest. It sold out early, and there's so much material, even that I had added on the plane ride over here from San Francisco, that we didn't even get to the last third of the material. So I want those people also to be able to experience. But in this workshop, and what we'll kind of talk about here today is there's optimizations at both layers, training side and serving side. And one thing, this is a bit insulting, and so sorry, data scientists, but my personal opinion is the training side's kind of boring, right? It's we know the algorithms. There's a lot of research going into faster algorithms. What we really enjoy is the system side of this, right? So taking those same algorithms and then making them faster by, different hardware tricks, things like that. And then furthermore, where most people stop is the training. And then they have this model, and typically they hand it over the wall and have it re-implemented in Java or in C or, God forbid, Python, right, to be on the runtime, and sitting behind a Kafka stream or behind a REST service. And what happens here is that the data scientist, has their view of Jupyter Notebook, or they're in, PyCharm or whatever they're using. And when that model goes to production, they completely lose insight into how that model is doing, right? So they might be able to tap into the ops guys, or find a dashboard that'll show like throughput or the response time for predictions, but really that's it. And yeah, they have to fight for that. And then also just this whole life cycle of being able to deploy quickly and see how the model's doing right away, right? Like within 30 minutes versus handing it over the wall, hoping it gets scheduled into the next 2-week sprint by the development team, by the ML engineers, and then it might go out a month later, like worst case scenario. And so one thing that I picked up at Netflix was giving people the ability to get to production and to test in production. So one thing Netflix did was they didn't do a lot of back of the envelope stuff. We just threw code out there and threw models out there. We had tooling to put it out on 1% traffic, or to put it into shadow mode where traffic's going to these models, but not affecting production. And so we'll talk about some of these canaries here. There's a couple different types of canaries. There's the traditional split canary, where you split off 1% traffic and 99 is going to the control. Or you can, like shadow canary, where you can sample 20% and send it over. So we'll show some ways here. We use like Kubernetes for this. We use this framework on top that's called Istio, I-S-T-I-O. It's istio.io. Yeah, by the way, I always try the other way and it never works. Okay, so, but yeah, real quick back to this slide. We find kind of the real-time part of this, the high availability, the high scalability. This is where, our team's interest comes from. And what we're trying to do too is make the deployment continuous for these models, and just from a notebook being able to actually deploy models, right? Like, how crazy is that? So that's the first thing that we do when we walk into a new customer, is say, right, like, how close can we get your data science team to production? And the first thing they say is, that will never happen, ever, right? And so we know this, but we always start with that. You always kind of, when you start negotiating, you start high, and then you, so like the next question is, how close can we get people, right, like these data scientists from Jupyter Notebook into the staging environments? And they're like, yeah, okay, that seems okay. And then, yeah, throughout the full life cycle, we start to, just keep hammering home that we would really prefer production. And once they get used to the tooling and things like that, then, so also too, like model serving optimizations, if you can make tweaks on the prediction side, so this affects millions and millions of users, right? So, for example, Netflix, I think, has 140 million users, versus there might be tens of training jobs going on during the day, machine learning training jobs, maybe hundreds, maybe there's a 50 like person data science team, but there's hundreds of these app developers that are using these models on the prediction side. So we're going to talk about part 0 here. This is the latest pipeline research that is related to the title of this talk, because we are reverse engineering Google Cloud ML, and sort of following along, but I'll show you guys a code later on. This is my way to keep you in your chair, by the way. I'm kind of bribing you to stay here. But I'll show you guys the code later, and that's where we'll actually get, there's about 90 more slides, after 0. So if you're willing to wake up, at like 9 a.m. on Saturday, please come. So this is the open source repo that we work out of. There's this really cool GitHub tool that you could use that'll actually map out. I think it's called Red Dwarf. If you Google Red Dwarf, make sure you put GitHub in there. If you just do Red Dwarf, a lot of weird stuff comes back. So. But you can actually put in just like anyone's repo, and within a half hour it'll show you the image. of kind of where people are. So since the last time I did this about a year ago, we have a big circle starting to happen up in London. We have a really big circle on the East Coast, so we're feeling pretty good about how this is going. We have about 13 contributors, and all of the workshop stuff, all of the stuff I'm going to show today, this is all open source. You can reproduce it on your own. That's for the workshop. So we've been working with these beta customers to really figure out what do they want, and what it seems that they want is an easy way to deploy models, tear them down if the models aren't doing well, right? So as part of our tooling at Netflix, as part of the contract that we had with our boss and our peers, was if we pushed out bad code to production, that there was enough metrics and there was enough error logging and enough insight that we could tear it down quickly. And this just doesn't exist today in the data science world, right? Think of the last time that you pushed out your model that was catching errors on the prediction side, or that was logging, timings for how long it takes to go from your JSON format into NumPy, and then calling scikit, predict method, and then transferring it back. That stuff doesn't exist. So we have all these open source libraries. It's just one call. It's just a with statement within Python, the Python context manager, and then all the code within there gets wrapped in a timing, and it shows up in your dashboards directly. So one thing that we do that's very unique, that's right from the start, is we take your model, right? So if you have a TensorFlow model, if you have a scikit-learn pickled model file, we actually burn that into a Docker image with the runtime. So for this particular runtime, so we like TensorFlow. There's a lot of nuggets that, there's a lot of room for optimization with these TensorFlow models that Google hasn't really done a good job kind of surfacing these. These are very low-level C++ things that you run. We cover them all in the workshop. I'll show some of them here. So I tend to talk about TensorFlow a lot, but just to remind you, we do support scikit and PMML, and if you just want to write Java code for your model, that just happens to be what you want to use. You can use that as well too. We support raw Python, Python 2 and 3. But what's unique is instead of just committing your model into source control or to putting it in an S3 bucket, what we do is we actually burn it in with all the libraries and everything that you need to make this model executable. And so this opens up a whole ton of really awesome use cases, because now you can tune not just the model, the traditional hyperparameters, right? But you could also tune the actual runtime itself. So I can create, this is version 1. Yes, I can create, version 2. This one specifying TensorFlow serving with GPU. I could specify TensorFlow serving CPU, right? What happens, yes, we see this quite a bit, where people assume that their model on the prediction side will run faster with GPUs, when really it's not, right? It's just not doing enough batching. The batch sizes aren't large enough to take that hit to go from the CPU to the GPU and back. There's other ways to tune that as well too. That's part of tuning at this model plus runtime, right? So it's just giving data scientists more knobs to turn. Right now, they can change learning rates. For your neural networks, you can change the depth of your decision trees, the number of times that you run through the data set. These are all familiar, but think of the ability to now tweak things at the actual runtime, to try out a CPU, try out a GPU. There's this new runtime that just came out by the NVIDIA folks that's called TensorRT, that can take your TensorFlow model, and it has a custom runtime that's not TensorFlow serving, but can serve TensorFlow models, and it's fully optimized for the NVIDIA GPU, right? So these NVIDIA guys know their GPU hardware very well, They know from generation to generation of GPUs. This is right, like full-time work just to keep up. From generation to generation, you can do the 16-bit, right, like half precision, that you couldn't do like previously. So it's kind of nice to rely on these guys and that they're now spending time on this serving layer and not just on the right, like training side of things. And so the other nice benefit here is if you've ever had that problem where you've trained a model, right, like locally, you've used scikit-learn, 0.18, and then you went to put it on the dev server, and that was 0.19, and you just happened to get lucky because you weren't using anything, that was incompatible, and then you go to production and someone updated scikit-learn to be 0.20, and now you're hosed, right, just based on. So you don't have to worry about that anymore. This is all packaged up into your Docker container, right? Like your like Docker image, and nothing changes from that point on. You just start it up. Either the web server starts up that's going to serve that model, or you have Kafka start up and connect to a Kafka topic, and now this model is consuming, from these topics, and you can scale them out horizontally that way. One kind of side note, this actually became really, 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 it sounds silly, but when Docker for Mac and Docker for Windows, right, like finally stabilized, and it wasn't clunky enough, where it was, you had to have VirtualBox that came from Oracle, and then, right, like that was always crashing, and you really had to know like a whole ton about IP tables and all that stuff. All that stuff went away, I think it was earlier this year. When Docker for Mac finally stabilized. And now it's just literally, it's just a little menu option up here. If it gets hosed, you just click restart and typically comes back. So now that you can go from your laptop, you can train on your laptop even with just a small sample. But one other cool thing you can do is, let me actually jump to this one, right? Like you could actually do a local load test, right? So you can start up with this. Yeah, this is all right, like pip installs CLI-pipeline. If you just grab the latest version, that'll work. And you just run this command. This is actually going to start the Docker container, and which has the runtime and has your model and exposes. So here's the model server URL that. Right, like box below is us calling predict, and it's calling localhost. And at the very bottom, you see test test request concurrency. So this is actually going to fork 1,000 processes on your local machine and just pound this like local model. And now, while this isn't a true load test that's going to represent production, right? If you've done this same exact thing with the version before, and you've done the same thing with the version after, and it's all on your laptop that has 4 CPUs or 8 CPUs or 8 gigs of RAM, whatever, it's more of a relative, right? Like from one, so I can get just at a quick glance with just 2 commands, I can start up this model and the runtime and pound it with a like little mini load test and just get a rough idea, right? Like, did this new model that I created, right, like maybe I created a model that's 100 layers deep, and it does really well on training, but it's taking 15 seconds per prediction, right? So this is something that you want to catch before you go out into production or out to staging, right? So just kind of a quick glance there. I mentioned so tuning the model and the runtime as a single unit. So you can actually create experiments that have multiple versions of the model and the runtime. You can play with the precision. You could try different runtimes. There's this post-training step. This is what I was talking about, where you could actually fuse layers together. At training time, you don't necessarily want to do this. Like you want those layers separate, so you can do things like dropout and some other advanced things for training. But when you're going to serve your model, it's just a forward propagation. So there's no reason to go back. So you can fuse together, make this math as fast as possible. And if you don't do this, there's a lot of performance being left on the table and these are systems level things that like data scientists shouldn't know about. But if there's one thing I've learned, it's that data scientists love data. And if I can give them, even locally, on their laptop, just a chart that shows, or even, yes, at the command line too, it's spitting out the times for these 1,000 requests. And yeah, so data scientists love data. It doesn't necessarily have to be like the typical validation accuracy, things like that. If you just show them like how fast is this happening, this can feed into the hyperparameter tuning. So maybe now you want to back off and not make it 100 layers deep. Let's go back to 20 layers and then sort of incrementally figure out where the right. So there's a couple different runtimes. Actually, this one just came out the 14th, was that a couple days ago when they made the formal announcement. It's called TensorFlow Lite. And this is actually very similar to what I was talking about. It's very similar to the NVIDIA TensorRT. So I'll just kind of talk about them both in the same way, where you take a trained model. So at the very top is a trained TensorFlow model. That's the same process. You write your TensorFlow code in Jupyter Hub. You run it on a distributed cluster or just local. And then there's this converter thing. And the output is this minimal version of your model that has just the bare minimum, to do your prediction. And by bare minimum, I mean bare minimum C++ libraries from TensorFlow runtime itself, the C++ kernels that are in the actual operating system, right? So it's literally going to start with your graph, right? Your TensorFlow neural network. It's going to traverse it as though it's doing a prediction, and it's just literally going to bundle together the bare minimum. If you don't do this, you need to pull in the entire TensorFlow runtime, which is 50 meg. And if your model's really small, you're now incurring 50 meg. And so, here we can get it down to 70K, right? So this is huge. This makes the difference of being able to deploy this model, on a really, really tiny device, right? Our cell phones are one thing. We've got tons of memory and pretty good CPU power, and we're starting to see TPUs and things like that end up, these custom accelerators coming into these phones. So yeah, keep an eye out on this. It's sort of, the context of this is more around mobile devices and iOS and that kind of thing, but really there's, some sort of, there's broader aspects to this. And so TensorRT does the same thing, except this is written by the NVIDIA folks. This takes your trained TensorFlow model and will generate this runtime that has all these memory, GPU memory tricks that only CUDA developers and the NVIDIA developers know. And of course, they're keeping it up to date with every generation. There's a lot more tricks. Yeah, these CUDA developers are like magicians. They're like wizards, right? And trying to know all these different ways to optimize GPUs with shared memory and things like that is a little tricky. So we talked about the local load test. Here you can actually push the Docker image out to your repo. Yeah, this is pretty cool here. So you can create, so this is where we would do a split canary. We have 97% traffic going to the version model A. We have 2% going to B, 1% going to C. But you could also do a mirroring or the shadow canary that I had mentioned before. We're building Jupyter extensions, so you could do it right from Jupyter itself. We're starting with the CLI because that's what a lot of our more sophisticated, kind of low-level customers have been doing. The key too is that you can tear these down. So as fast as you can deploy them, you can also pull them back. One thing to kind of leave you guys with, this is our favorite chart or our favorite dashboard. It's a single view into how these three models that we're pinning against each other, how they did offline, which is where data scientists typically end. They don't really see much beyond, Then that middle one is an interesting view. This is something that might take a sec to sink in, but what we're doing is we're shadowing traffic. This particular experiment was taking the same features coming in, so the same search query terms or the same customer segment or like whatever's happening, right? Like whatever the application is trying to pass to get a prediction back. And for those same inputs, we are tracking what the actual outputs are, right? And if you have, for example, like a top 10 list, like top 10 recommendations, you could use something like Jacquard similarity, which like lets you compare two sets. And this is kind of linear regression. If maybe this is the like Airbnb where you're trying to find a price based on how many bedrooms, how many like bathrooms that your room has that you're trying to rent out. But think of like another dashboard where what we're trying to do is to find a model that tracks similar to that current control model, and then but find something that's faster, that will actually predict faster. And so, so by tracking and sort of quantifying that, right, like output from these predictions, we could see which ones are tracking closer to the control. B is not doing well. C is tracking well. At the bottom is the like latency response time. So C is doing really well there. There's one other cool metric that's kind of buried in there that you'll see with the $sign. That's cost per prediction. So I'll show. So let me jump right into. So this is one other dashboard, right? So we actually deploy the same models. This is right, like one demo that we do where we deploy the same models on two different clouds. And throughout the day, at the beginning of the day, right, like maybe Amazon is cheaper because we can run our predictions on spot instances, right, which are typically half or 40%. And then as we start to lose our spot instances, now Google becomes cheaper per prediction. And so we can actually automatically shift traffic over to Google. And then, keep some servers running within Amazon, but have them both in like both clouds, and then shifting traffic across. Also on-premise too, this is all Kubernetes based, so. Okay, and I think I'm out of time based on, am I out of time? Yeah. Am I over time? All right, so if you go to Pipeline AI, in the upper right is this tab called Workshop, and just know Big Data Spain 100 is 100% off, so hop on there. I give everyone your own GPU, and we will go through the next 90 slides on Saturday. So. Yeah, there's a lot of good stuff. If you're interested, we're going to optimize. We're going to train a model. It's very, very GPU heavy. Yeah, let me go back to this slide. So yeah, come join us for that. Thank you.